Hello everyone. In today's lecture we are going to discuss about mission design and the factor governing the mission design or the design of mission elements. Before I talk about mission design, let me tell you what exactly mission means. Mission is defined as a combination of kinetic links which transforms available energy into required mechanical work. Mission design deals about sizing of mission parts or elements. It also deals about the preparation of drawings for the fabrication purpose. Design of mission elements is an art of developing new ideas, new drawings for the construction of missions or its elements or parts. The elements must be designed to stand the required loading conditions and must satisfy the required functional parameters. It also considers the fabrication in the most economical procedure. In simple words, design of mission elements is defined as the determination of sizes, shapes of mission elements by mechanical engineering concepts to produce effective and economical mission elements. The basic mission elements are like we will be seeing number of mission elements in the real world: screws, nuts, bolts, key joints, shaft couplings, welding joints, rivets, belts, chains, bearings, clutches, whatnot. There are number of mission elements which are being designed by us. Coming to the classification of mission design. Mission design is classified into three types of on the basis of engineer's idea. The first one is adaptive design. Adaptive design is existing ideas. The next one is development design. Development design is like modifying the existing idea, like trying for better efficiency or changing the dimensions or designing a component which is more economical by reducing the cost of manufacturing or production. This is development design. The next one is new design. New design is solving a new problem which is being faced by the world or showing the solution for the problem. For this, lot of research, technically skilled and advanced idea is required. Next, we will be talking about the various factors governing the design of mission elements. There are number of factors, so we will go one by one. Coming to the factors which are being governing the design of mission elements. The first one is load, the next one is mechanism, the next one is selection of materials, manufacturing processes, shape, size and quantity, cost, durability and reliability, safety, effect of environment, frictional resistance and lubrication, workshop facilities, life. So, if you see, these are the various parameters which are affecting the or which are governing the design of mission elements. Let me go with the first one, that is load. In design of mission elements, the external forces acting on the mission elements are considered as loads. The following types of loads are considered to design the mission elements. Like according to the nature of load, the first one is tensile load, when the section or element is subjected to two equal and opposite pulls, tensile load. If you see the second one, it is compressive load, when the system is subjected to two opposite and equal pushes. Third one is shear load, when the system is subjected to tangential loading in clockwise or anti-clockwise direction. Apart from this, we have we have different loading conditions, like we can take bending load, we have torsional load, twisting load. So, these are some special loading conditions we can say. The next one is according to the method of load application. Like the first one, if you see, it is gradually applied load. In gradually applied load, we can take steady load or dead load. Okay, let me give you one example. If you see an automobile, the wheels of the automobile has to bear the weight of the total body parts. It becomes the dead load for the wheels. So, that is dead load. The next one is live load or variable load. When you are on the vehicle and moving with a uniform velocity, so the vehicle will have uniform load, that is steady load. The next one is variable load. You are trying to accelerate and try to change the speed of the automobile. So, it is variable load. Next one is shock load. When the vehicle is moving and you are trying to move on the speed breaker. So, that is shock load, that is suddenly applied load. The next one is impact load. Impact load is the load which comes with a higher velocity, like you can take as example of accidents. More the velocity, more the impact, more the destruction. So, that is impact load. So, these are the different loading conditions which we need to consider when we are trying to design a mission element. Next one is mechanism, right. The design process deals about the selection of suitable mechanism to the required mission part or mission elements. The simplest arrangement and the required motion of mission element causes successful operation of the mission. So, the mechanism is important, but it should be arranged in the simplest form. More the complication, more the loss of energy. So, that is more important. So, we have to get the ultimate successful operation by arranging it in a simplest way. So, what are the different types of motions we have? One is rectilinear motion, curvilinear motion, how it is moving with a constant velocity or a variable velocity, variable in the sense constant acceleration or variable acceleration. So, we are talking about the mechanism, how it should be. Next is selection of materials. This is one of the most important parameter when we are going to design a mission element. The designer must know about the properties of the engineering materials. Then the designer selects the type of required material for the required mission element. Apart from the properties of the elements, these are the various factors which he has to think about: size and shape of the element, availability of the element, cost of the element, type of loading, manufacturing. If he has selected the element, can he draw that particular material to that specified shape and size? Next is availability of the material. You have established an industry in Hyderabad and you are trying to select a material which is not at all available in the Hyderabad. You need to you have selected somewhere where the material is available in Punjab. So, your cost of production increases due to the unavailability of the material. So, where is the question of getting the component in a more economical way? So, availability of the material is most important. The next one is cost of material. Cost of material. If you see, the wires are made of copper because they have ductility property and they are good electrical conductors. If you see, silver also is a good electrical conductor. Apart from that, it is also having good ductility property. Why don't we use silver in spite of copper? Because the cost of silver is more. So, affordability. So, you have to see what is the cost of the material. The designer should design a mission component which is economical. That is one of the important point what a designer should think about. Next is type of loading. Next is manufacturing. Like if the material which we have chosen does not have missionability property and we need to mission it. So, we can't do the manufacturing for the selected material. So, where is the question? So, when we are selecting the material, all these properties should be satisfied. So, these are the various things. So, I talked about when we are talking about the selection of material, the first one is we should consider the mechanical properties of the materials. That is one of the most important thing, right. So, these are different mechanical properties. First one is strength. What is strength? Strength is the ability to resist the external load without breaking. So, it should not fail, it should resist the load, that is strength. Elasticity, We have learned about this particular statement since our childhood. Property to regain its original position soon after the removal of load. Steel, rubber, these are elastic materials. Next is plasticity, just opposite to elasticity. Property to set up with permanent deformation after the removal of load. So, plasticity, I can tell you something which will have appreciable deformation after the elastic limit before failing is plasticity. So, we have clay, we have lead, which are highly plastic materials. Next is ductility. Ductility, a property to be drawn into wires. Ductility. Malleability, property of being drawn into sheets. Gold, silver, copper, aluminium are the examples for malleability. Hardness, property of resisting indentation, scratching, machining, it is hardness. Next is toughness, property of resisting fracture due to shock loads or impact loads. So, that is toughness. Resilience, amount of energy observed by the material up to elastic limit. Resilience is a property of what is the amount of energy it can absorb up to elastic limit, that is resilience. Stiffness, stiffness, ability to resist deformation and strain. If you see strength and stiffness, designers will select a material which has most stiffness sometimes, though they have same strength. Let me tell you, I have two material A and material B. Both of them have more or less same strength, but material A, material B, if I applied same load on both the materials, it bears the load by deforming. It bears and material A is bearing the load and material B is bearing the load. So, both of them have same strength as I told you. Material A is deforming while taking the load and material B is not deforming while taking the load, while carrying the load. So, we say that material B is having high stiffness value when compared to A, that is stiffness. So, stiffness is one of the important parameter the designers consider while selecting a particular application. Next is brittleness. Brittleness, property of breaking with little permanent distortion. Fatigue, failure under repeated or several load applications. So, it is a fracture or a crack formed at micro level, that is fatigue, start of crack at the micro level. Creep, creep is slow and progressive deformation of the material due to constant stress for long period of time. Generally, we talk about long period of time and sometimes creep is referred to the availability of bearing the load under high temperature values. So, both come under creep. These are mechanical properties. Come to the next one, that is shape, size and quantity. The required shape, size and quantity of mission elements to be produced. Find the economical manufacturing procedures or processes to reduce the cost of the production. Mission elements should have simple shape and larger quantity. So, while designing the shape, size, what we have to take into picture, we should reduce the cost of the production. So, the shape should be as simple as possible. Next is cost. To estimate the cost of mission element, its quality should be considered. So, generally the cost of the mission element increases with the increasing of its quality. Hence, the aim of the mission designer should be to design a mission component of defined quality at low cost. So, again I am repeating this. The aim of the mission designer should be to design a mission element or a mission component of defined quality at low cost. So, we should able to obtain the defined quality at maximum low cost. So, that is the point where we have to think about. Next is durability and reliability. Durability, it is just the ability to resist the adverse effects of environment or maintenance and use of element with the process of time or progress of time. So, it is the ability to resist the adverse effects of environment is durability. What is reliability? Elements availability or elements ability to perform required function for given condition and specified time period, that is reliability. Elements ability to perform required function for a given condition and specified time period, that is reliability. Next is safety, one of the important factors which we need to consider. Every mission of every industry, should be properly operated by every operator or designer, because every mission has its own proper safety operational techniques. Hence, every operator must have adequate safe operating skills to operate the missions to avoid accidents. So, while designing, we have to keep this point into mind, that we are designing a mission element which is safe and which is very simple to operate and which is having safe operating what we call techniques. So, it should have safe operating techniques. So, that is one of the important point we need to consider. Next is effect of environment. One of the factor of mission design process, normal environment is considered as the environment for designing a mission element. Generally, environment causes corrosion or to the materials like dirt, dust, formation over the surfaces of the mission elements. So, to avoid the corrosion on the mission elements, it must be covered by non-metallic washers. So, to avoid dust and dirt particle formations, some major precautions should be considered. So, if you are seeing the environmental conditions, we need to consider, like if we are designing a surface for a marine industry. So, in the marine industry, if you are going with the marine industry, so you have to see a material which is which can have life in sea water, that is the water which is salty. So, depending on the environment, you have to see the material life. Next is frictional resistance and lubrication. The mission elements having different types of relative motions like sliding, rolling or rotating. These actions of mission elements produce different types of frictions. It may be static, it may be kinematic, so it may be rolling types of frictions, whatever it is. Generally, the friction of starting is higher than running friction. So, any type of frictional resistance causing loss of power. So, we have to minimize the loss of power. So, the effect of frictional resistance should not affect the working condition. So, what we have to do is we have to apply proper lubrication. We need to see where the lubrication needed to be applied. The proper lubrication of all the sides of the mission elements produces minimum loss of power. So, that is frictional resistance and lubrication. The next point is workshop facilities. A designer should have adequate information of his employee's workshop. So, if I have designed a mission element which can be manufactured in the facility which is available in the industry, so how can we expect a design like that? So, we should know what are the facilities which are available in the workshop, so that we can design a better mission element. So, To draft methods like fabrication, designer required for the total plan of workshop, location of each machine, location of stores, casting unit, forging unit or assembly unit, inspecting unit. So, based on the workshop plan, designer should execute the sequential steps for the required fabrication to avoid unnecessary movements of the machine element. Hence, it provides the best economical way of production. So, the designer should have all the idea about his workshop plan, that is this point. Next is life, one of the most important point. Life of the product is defined of the length of the time or the number of times it is operated before failure. If the machine element works longer time than its defined time, then it causes high production cost. In a similar way, machine component works shorter time than its defined life, then it also causes high production cost. So, I'll repeat the statement. If the machine element is working longer time than the defined time, so it causes low production cost. In the similar way, if the machine element is working shorter than the defined time, so it causes high production cost. Besides the above factors, the designer should also consider the use of standard parts, number of machines to be manufactured, assembled, market needs, maintenance, appearance, all this. So, these are the different factors which influence the design of machine element. Thank you.